I'm going to give you a series of problems. A problem might look like this. Write an identity function that takes an argument and returns that argument. And I'll show an example of how you would call it and what the result of that call would be. I will then give you some time to work on it, probably about 10 minutes or so. Some of you are going to work faster than others, so for those of you who finish quickly, you're going to get frustrated because you're going to have to wait for the time before we go on. And for some of you are going to be working slower, and you're going to get frustrated because you might not have enough time to finish every problem. So my goal today is to frustrate everybody equally. Okay, that's where we're going to be going with this. So you'll take some time, you'll work on the problem, you'll come up with a solution. I will then show you my solution, and in some cases I may show you multiple solutions. And you can compare yours with mine. If you like mine better than yours, you want to record it, because each of these later problems will refer to earlier problems, either in pattern or will actually be calling the earlier functions. So make sure that you get at least one version of everything that works. Also, I highly recommend that you use exactly the same function names that I do, because later we're going to write functions which call these functions, and if you're giving them different names, it'll be really easy to get confused. Okay? Then you'll probably want to test it. If you have a JavaScript engine on your machine and you know how to use it, for example, if you have Node installed and you know how to use the REPL, that's great. You can just plug it in there and it'll work. If you don't, you have at least one web browser, and all the web browsers now come with very nice debuggers, so you can do that as well. This is one way to use a web browser. You could simply have a form like this, or a page containing a script tag. For my convenience, I created a log function so I could log results, and it'll just write them to the screen. Then in the box, I've got the function that I wrote, and then I called the function sending the result to the log. If you want to do something more sophisticated, you're certainly welcome to do that. This is sort of the minimum that you need to get started. You don't have to test your functions, but you probably want to, right? Because otherwise you can't have confidence that they're working correctly. While everybody is still getting set up, we're going to do a quiz, pop quiz. So here we go. Ready? Question number 1. We have a function called funky. It takes an argument O, sets O to null. We create a global variable x, which is an empty array. We pass x to funky. What is now the value of x? So who thinks x is null? And who thinks x is the empty array? And who thinks it's undefined? And who thinks it'll throw an exception? Okay, the answer is B, the empty array. So let's look at what's happening here. So we start off, we have the global variable x that points at the array. We pass the contents of x, which is that reference to funky, which has it bound to O. We replace O with null, and there you are. So funky as written is a completely useless function. And this thing about the way variables work is not peculiar to JavaScript. Almost all modern languages work this way. Most languages do not allow you to pass a reference to a variable. What they allow you to do is to pass a reference to the contents of the variable. Okay? Algol 60, which was a brilliant language, had something in it called call by name, where you actually could pass a reference to a variable. That was one of the very few very bad ideas in Algol 60. Ready for another one? Okay, here's a function swap. It takes two arguments a and b, and it swaps them using a temp variable. We have two global variables, x and y, whose values are 1 and 2. We pass x and y to swap. What is now the value of x? So, who thinks x is 1? Who thinks x is 2? Okay, I'm not going to fool you this time. The answer is 1. And it's similar to what we did before. So here we've got our two global variables, x and y, that point to 1 and 2. We pass x and y to swap. Then we fiddle them around with swap, but that did not change what X and Y are doing. I'm hoping that someday in the future, JavaScript gets macros. So instead of saying function swap, I'd say macro swap. And in that case, macros do get called or do get passed with variable names, and macro swap would be a useful thing. But as written, function swap is pretty useless. Okay, any questions about the quiz? Okay, quiz is done. It's time to do some real work. Are you ready? So the first one is going to be totally trivial, no tricks. It's just something to allow you to test your environment. So write 3 binary functions. A binary function is a function that takes 2 arguments, add, sub, and mul, that take 2 numbers and return their sum, difference, and product. Okay, this is as trivial as it sounds. There are no tricks. We're doing this so that you can practice, and also so that we'll have functions that we write later will be able to call. So here we have add, first, and mul. I assume that everybody got this, right? Yes? Who got this? Yeah. If you didn't, write it down because you're going to need these for later. Okay, ready for the first interesting problem of the day. Here we go. Write a function identity f that takes an argument and returns a function that returns that argument. So we're going to call identity f, we're going to pass it 3. That will return a function. When we call that function, it will return 3. So here is identity f. Identity f takes an argument and it returns a function that returns that argument. So who got identity f? Very good. If you didn't get it, write it down because you're going to definitely need it later. And don't be discouraged. I'm not expecting everybody to get every problem. What I'm expecting is that everybody gets the last problem. Okay? So if you don't see what's going on immediately, just stay with it. Eventually the patterns should start to become clearer and you'll get a sense of where we're going. Okay? Any questions so far? Okay, we ready for the next one? Okay. Write a function add f that adds from 2 invocations. So if we pass a 3 to add f, it will return a function. If we pass 4 to that function, it will return 7. So here's add f. Add f takes a first argument, it returns a function that takes a second argument, and it returns the result of calling the first and second argument. So who got add f? Okay, very good. If you didn't get it, write it down. You're going to want to need it for the next one. So this problem was suggested to me by Dmitry Barnovsky, who is a brilliant Ukrainian programmer living in Sydney, Australia. He's the author of Raphael JS, a very nice graphics package for the browser. He suggested that this should be a hiring question. And if you got this right, maybe you think so too. So, we ready for the next one? Okay, here we go. Write a function liftf that takes a binary function and makes it callable with 2 invocations. So if we pass the add function that we wrote the first thing this morning to liftf, it returns a function that works exactly like the addf function that we just wrote. And to make it even more interesting, we can pass other binary functions like the multiply function and get a similar kind of capability. Let's look at liftf. Liftf takes a binary function, it returns a function that takes a first argument, that returns a function that takes a second argument, that returns the result of passing the first and second arguments to the binary function. So who got liftf? Very good. If you didn't get it, write it down. You're going to want to need it for a later one. This is an example of a higher order function. Higher order functions are functions that receive other functions as parameters and return other functions as results. So we're starting to get moving down the rabbit hole into a very interesting way of constructing things. Write a function curry that takes a binary function and an argument and returns a function that can take a second argument. So here we'll pass to the curry function the add function that we wrote this morning and 3. It will return a function that will add 3 to things. Similarly, we could pass to curry the multiply function in 5, and it will return a function that will multiply things by 5.
We did curry yesterday. Let's see.
It's all come full circle.
Waffle balls.
Yeah, it's not uncommon when I introduce this problem that some people will perk up and go, oh, curry, this is finally starting to get interesting.
In the previous solution, you had a var addf.
Mm-hmm.
And earlier on, we had a function addf.
Yep,
And JSLint complains that it's a redefinition.
that's right.
And is...
And JSLint is right.
Okay.
Okay, so here's the curry function. Curry takes a binary function and a first argument and returns a function that takes a second argument and returns the result of calling the binary function with the first and second arguments. So who got curry? Very good. If you didn't get curry, get it now because you're going to need it later. Now, another way you could have written curry is you could have used the lift function that we wrote earlier. Did anyone use liftf? That'd be extra credit if you'd done that. So this process of taking a function with multiple arguments and turning it into multiple functions that take a single argument is called currying. And it's named after Haskell Curry, who was a mathematician who did a lot of work with Church's lambda calculus. And by normalizing all functions to take only one argument, it made a lot of operations easier to think about. Some people think it should be called Schoenwinkelization, because there was a fellow named Schoenwinkel who was doing this stuff earlier, but we're going to call it currying. Now, some people would like curry to be able to work with functions of any number of arguments. And it's possible to do that with JavaScript. And it is horrible. It's terribly ugly. So if I want to have either of the two functions take any number of things rather than just the one thing that we're concerned with, you have to do that. And it's inexcusably awful. And it's because the arguments array isn't really an array, and so it doesn't work right, and so you have to do all these tricks in order to get things to happen. And I'm not going to explain what this does because I just don't want to waste time on it. It's awful. And so because of this awfulness, all of the functions that we write today will only take a fixed number of arguments. So we'll have unary functions that will take one argument and binary functions that will take two arguments. Even though lots of the applications we're going to do would really like it to be variable, I don't want you to have to waste your time on this because, you can see there's a whole lot of stuff going on that has nothing to do with curry. Now, in ES6, which is starting to find its way into implementations, there's some new syntax with the ellipsis operator, the ... operator. And if you put the ellipsis in a parameter list, what that says is take all of the rest of the arguments, all the remaining arguments, put them into an array, and bind that array to that parameter. And that is so much cleaner. And then on the call side, in an argument list, if you go ... and there's an array there, it says take that array and spread it out. So each element of the array will be a separate argument. And so by doing that, we've got this version of the curry function, which looks exactly like the first one, except it's got the annotations in it, which says this is where you can have a multiple number of things being passed. And, both of these do exactly the same thing. Which one would you rather be reading? I'm guessing it'd be the second one. So when ES6 becomes everywhere, then I'll change this course so that we'll be writing functions that look like that. Yeah?
That was kind of a question I had for you yesterday, but it's fitting now. So when you were seeing the advent from ES3 to ES5, did that take a long time for browsers to adopt? Or do you see us moving a little faster now, or is it still going to take quite a while to get ES6 adopted fully?
It's faster. The big hang up with ES5 was the IE problem. And IE is not nearly the problem that it was before. And all of the other browsers are out updating, so the problem isn't propagation and adoption. The problem is now just implementation. So I'm hoping that we'll get all of this stuff out much faster. So anyway, ellipsis will be my second most favorite feature in ES6 if it ever gets finished. So that'll be great. But in the meantime, we're only going to be concerned with functions taking a fixed number of arguments. Okay? So are we ready for the next one? This next problem is going to be a little bit different because you are not going to write any new functions. Instead, you're going to be using functions that we have already written. So without writing any new functions, show 3 ways to create the inc function. The inc function adds 1 to a number and returns it. So if you pass 5 to inc, it'll return 6. And so you're going to call a function which will create the inc function. And you're going to show 3 different ways to do that using functions you've already written. So here are 3 ways to do inc. First one is addf of 1. Who got that one? Okay. And the next is liftf of add and 1. Who got that? And curry of add and 1. Who got that? And who got all 3? Very good. So this illustrates the first rule of functional programming, which is let the functions do the work. If you've already written a function that does what you need, you don't need to write another one. Write a function twice that takes a binary function and returns a unary function that passes its argument to the binary function twice. So by twice, I mean this. We've got the add function. We're going to add 11 twice. Okay, that'll produce 22. So we're going to automate that. We're going to make a twice function. We can pass add to that, and it will create a double function which does the same thing. We could also pass the multiply function to twice. It will produce a square function which will square things. Now, I intentionally misspelled the word double because in some implementations double is a reserved word, and if you spell it correctly you'll get a syntax error, which is inexcusable since double isn't even used in this language. But so I misspelled it. I recommend that you misspell it too for the same reason. So here is twice. Twice takes a binary function, returns a function that takes an argument, and it returns the result of calling the binary function with that argument twice. So who got twice? Very good. If you didn't get it, write it down. You're going to need it for another one. Any questions before we go on to the next one?
Only a dumb question. I was trying to figure out if there was a way to define this using curry or liftf.
There probably is, but it's probably just as well that you didn't.
All right.
So if we did, would we want to change it to that implementation?
That's up to you. The most important thing today is that it works. Okay, ready to move on? Okay, here's the next one. Write reverse, a function that reverses the arguments of a binary function. So we're going to pass to reverse the sub function that we wrote this morning, and it returns the bus function, which is subtract backwards. So if we pass 3 and 2 to bus, we'll get -1. Okay, so here's reverse. Reverse takes a binary function and returns a function that takes a first and second argument and returns the result of calling the binary function with the second and first argument. So who got reverse? Very good. So this is how we'll write it next year. We'll be able to reverse any number of arguments. So we're starting to get into practical stuff now. So you might imagine you've got 2 APIs and you need to make them work together, but they were not designed to work together, so their calling sequences are incompatible. And you could rewrite one of them to be more like the other, but that's too much work. Or you could write a wrapper function around every entry point of one, but that's too much work too. With this approach, we could let functions do that work. So we can have functions write wrappers which will allow us to use them interoperability or interchangeably. Okay? So ready for the next one? Write a function compose U that takes 2 unary functions and returns a unary function that calls them both. So we're going to take the double and the square function that we wrote earlier, and we're going to pass them both to compose U. And then we'll pass the function that it returns 5, and it will return 100. And it'll do that by taking the 5 and doubling it, and then taking that and squaring it. So here is compose U. Compose U takes functions f and g. It returns a function that takes an argument and returns the result of calling g of f of a. So who got compose U? Very good. The tricky thing about this one was that nested function invocations are written inside out, which lexically looks backwards, and so you just need to get the G before the F, even though it's called later. So this introduces a way of programming which is kind of like adding Unix pipes, except at the function level, that we can take existing functions and kind of string them together and pass values through them, and it'll go through this chain of functions until something comes out the other end. So next year when we write this function, we'll allow it to take not 2 functions, but any number of functions, and then you can just program a whole series of things. Until then, you could call compose use several times, each time adding a new function to the list. Sort of like currying, I guess. Okay, any questions about that? Ready for another one? Anybody? Yeah, all right, good. All right. So write a function compose B that takes 2 binary functions and returns a function that calls them both. So we're going to pass add and mul to compose B, and it will return a function, and if we pass it 2, 3, and 7, it'll return 35. So here is compose B. Compose B takes 2 functions f and g, returns a function that takes a, b, and c, and returns the result of calling g of f of a and b and c. So who got compose B? Really good. You guys are doing great. Feeling good? Yeah? Okay. Want to do another one? I've got another one. So let's go. Write a limit function that allows a binary function to be called a limited number of times. So we're going to pass the add function to limit and say you can use it 1 time, and that will produce a limited add function. We could then give that to a third party, and the third party can call it once, and it works just right. But if they call it a second time, all it does is return undefined. It doesn't do anything else. Okay, you could pass a wish function to limit and say you only get 3 wishes. And the wish function can make any number of wishes, but the function that we hand you will have a limit on it.
Does the function you pass have to be a binary function?
Let's say yes.
Okay.
In the future, we want it to work with anything, but for today, we'll just say a binary function.
Okay.
So here's limit. Limit takes a binary function and a count, and it returns a function that takes 2 arguments. If the count is greater than or equal to 1, it decrements the count and returns the result of calling the binary function with the 2 arguments. Otherwise, it will return undefined. So from this point on, the functions are starting to get a little bit more complicated, so it's unlikely that you did the same thing I did. So from this point on, I'm going to ask, who got something that works? Okay, very good. Anyone do something interesting, a different approach?
I used a variable instead of, I had 2 variables instead of just 1.
Okay, and where did you put them?
Before return function, I set max. No, max was, I said I equal to 0, and count I used max. And then each time I ran function, it just incremented I by 1.
Great, very good. So, anybody else?
Well,
Yeah.
I'm a little confused how the count, or how is this being stored? How is the number of times it's being...
Well, we're using closure, right? So the inner function has access to the variables and parameters of the outer function. So it sees the count and is changing that parameter.
Do you need to return undefined there?
Yeah, so that's a really good question, and that's why I underlined this statement, because I want to talk about it. So there are 2 schools of thought on that statement. One is, this is completely unnecessary, because in JavaScript, if a function falls off the bottom, it returns undefined. So this is just a waste of space. There's no reason to say this. The other school of thought is that part of the contract for this function is that it returns undefined when the limit is reached. And so by explicitly returning undefined, we're providing self-documenting code. I think both points of view are valid. I've not been able to decide which one is better, so you'll see me flip-flopping on this. The thing that is clearly bad would be saying just return semicolon, because that doesn't accomplish either thing. It's a waste of space, and it isn't explicit about what's being returned. Yes?
You answered my question right there.
Okay. Anybody else?
I had something maybe less clever. I had a local variable call, which I initialized to 0, which was the number of calls made.
Okay, and the local variable was stored above the return statement?
Before the return.
Brilliant. Okay, very good. Write a from function that produces a generator that will produce a series of values. So we're going to pass 0 to the from function. It will return a generator. In this case, I'm calling it index. Every time I call index, it will return the next value in the sequence that started with the starting value.
What's a generator?
A generator is a function that'll make things. So each time you call a generator, you'll get another thing. In this case, we're making a generator that's going to produce a sequence of integers starting at some value. Okay, so here is from. From takes a start value. It returns a function which computes the next value simply by taking start. It adds 1 to start and then returns next. So who got something that works? Okay, very good. Anybody take a different approach? Yeah?
I just in the inner function, I just did return x plus equals 1.
Okay,
Does that work?
sure. Anybody else?
That won't give you the starting point you fed in. You fed in 0, it'll start with 1.
Yeah, he's right.
You won't like this. I did return start plus plus.
Yeah, there's always one of those. Anybody else?
Oh, you want to get start the first time?
Yeah, start wants to be,
Yeah.
if we
Yeah.
say from 0, we need to start with 0.
You need ++1. But
Yeah, but we're
you
not,
return plus start.
yeah, but we're not doing that.
Yeah, I know you're not doing that.
Okay, ready to move on? Okay, here's the next one. Write a to function that takes a generator and an end value and returns a generator that will produce numbers up to that limit. So we'll pass to the to function a generator that we make with our one function, or with our from function. So we'll pass from 1 to 2, and we'll also pass it a 3, and it will return a generator which will return values up to the limit to 2, and from that point on it will return undefined instead.
So unlike the previous limit, this one does not include the limit? Or is it last one was limited number of times?
Right.
This is
to a value.
upper ceiling, not including that ceiling.
Right.
Maybe we should call it almost instead of to.
Well, this is the convention we have in our languages, right?
That's true.
When you're taking a substring of something, this is the way we do it.
It's a zero-based index.
Yeah. So here's one way to write the to function. To takes a generator and an end value. It returns a function that gets the next value from the generator. If that value is less than the end value, it returns that value. Otherwise, it returns undefined. So who got something that works? Very good. Anyone take a different approach or do something amazing? Wonderful, spectacular, anything like
How
that?
amazing it is, but mine looks very similar to the limit function. It just uses the from generator inside of it. So I set a variable in the outer scope and then add a number to that, and if that number is less than or equal to the limit, I return, or greater than or equal to the limit, I return undefined, otherwise I return the generator.
Okay. Anybody else? All right, want to do another one? Yes. All right, let's do another one. Okay, let's write a from to function that produces a generator that produces value in a range. So we're going to pass to from to 0 and 3, and it will get us the generator that gives us a sequence 0, 1, 2, and then undefined. So here is from to. From to takes a start value and an end value, and it returns the result of calling to, passing it from start and end. So who got something that works? Very good. Who did it the hard way? Yeah. First rule of functional programming, let the functions do the work. Write an element function that takes an array and a generator and returns a generator that will produce elements from the array. So we're going to pass to the element factory an array containing A, B, C, and D, and we'll give it a generator which does from to 1 to 3. And that will give us a generator which will produce B and C, and then undefined. So here's element. Element takes an array and a generator. It returns a function that gets the next index from the generator. If the index is not undefined, it returns the next, or the element of the array at that index. So who got something that works? So I want to talk about the statement that's underlined. Because if you leave that if out, if we do the return unconditionally, it does the same thing. And the reason it does the same thing is kind of weird. So, excuse me. If we don't have the if there, then if index is undefined, then the brackets will turn undefined into the string undefined. It will then look for the member undefined in the array and not find it, and return undefined, which is what you return if you can't find something. So it kind of accidentally works if you leave that test out, except in the case where if someone creates an undefined property in the array, then they can cause the behavior of this function to change in that case.
So if you were to call like delete on a node in the array.
Well, no, not deleting a node. If you said array, if we said, what are we calling the array? Yeah, if we said array dot undefined equals 5, then in that case, we'll return 5 instead of undefined, which might not be what you want. And so, while most of the time it works, I'm concerned about the weird cases, which are what actually screw you up in production and in life. And so I would rather be explicit and look for that case. Anybody else do something different?
I just returned the array. I didn't do the test.
Yeah.
I just returned array gen.
Mm-hmm. Yeah,
Because
like
there's too much typing.
that will almost always work. Modify the element function so that the generator argument is optional. If the generator is not provided, then each of the elements of the array will be provided. So we can call element passing the array A, B, C, and D, and we will get a generator which will return A, B, C, D, and undefined. So here is the revised element. All I did was add the code that's in the yellow box. If we didn't get past a generator, then we'll call from to and get a new generator. Otherwise, everything else is the same. So who got something that works? Did anybody try to do it the hard way? First rule of functional programming, yeah. Let the functions do the work. So I want to talk about the condition that I underlined. There are 3 ways I could have written that. That's the first one, where I'm looking explicitly, did undefined get passed in, which means did nothing get passed in. Another way I could have written it is the type of gen equal to function? So if they passed in something but it wasn't a function, we'll make it a function. So the difference between those 2 approaches is the second one will tend to always succeed, and the first one will tend to fail if something bad was passed in. And it depends on the characteristics of your application. Generally, fast failure is what you want because it helps you discover bugs faster. But sometimes you've got code which is really critical and you want to be sure that no matter what happens, this code's going to be working right. The third way you could write that condition would be to do a bullish check. You know, if not gen, then do something. And I don't like that because what we're trying to do in making the condition is divide the whole universe of possibilities into one of two states. It either is or it isn't. And the bullish case splits it in a really weird way, in that if they pass in a 1, the behavior will be very, very different than if they passed in a 0. And it doesn't make sense to me that 1 and 0 should behave that differently when we're looking for a function. So this is why I think that JavaScript depending on bullish values in conditions was a mistake. And I recommend always be more explicit. You know, either figure out, do I want the fast failure question, or do I want the will seem to always succeed question, but not the convenient one which can straddle both of those in unexpected ways. Yeah?
Why not just generator equals from 0?
In that case, that'll work fine too. You know, from will keep going forever, but we run into the undefined thing, so it'll stop. So from by itself is also okay. Anybody else?
So you see a lot of, I don't know, minifiers do this, and some people would write this code like gen equals gen or from to 0 array length. You know, it's a funny syntax, but like I say, you see a lot of minifiers. But I don't think it would minify this code the way it's written that way because of, you said undefined, as opposed to the bullish way.
Right. So I used to recommend using the logical OR operator to do something like you're suggesting, you know, to replace default values. And I've stopped recommending that because it's too hazardous.
Yeah.
That if someone passes in a 0, 0 is falsy, and so it might get replaced in cases where you don't expect it will.
Right.
And that's problematic. So I now recommend instead be explicit. Don't depend on bullish checks. Write a collect function that takes a generator and an array and produces a function that will collect the results in the array. So we're going to make a generator that works like the NSA. It's going to spy on a function and record everything interesting that that function returns. Okay, so first we'll set up the empty array where collect is going to keep its stuff. Then we'll call collect, passing it any generator and that array. And it will return a generator which will work exactly like the first generator, except it will record everything that it returns except for undefined. So we can call that generator a few times, and then we can look at what's in the array, and it will have captured those values. So here is collect. Collect takes a generator and an array. It returns a function that gets the next value from the generator. If the value is not undefined, it pushes it onto the end of the array. In either case, it will return the value. So who got something that works? So close. Anybody do something interesting?
Can you just return array.push value instead of having the return value outside of the
I don't recall what it is that array.push returns. I think it might be the updated length of the array. Does anyone know?
Yeah, that sounds right.
Yeah, so unfortunately, array.push isn't smart enough to do that. Anybody else? All right, shall we go on to the next one? Write a filter function that takes a generator and a predicate. A predicate is a function that returns a Boolean, true or false, and produces a generator that produces only the values approved by the predicate. So in this case, we're going to be filtering using the third function. The third function will return true only if its argument is divisible by 3. So we'll use that to select factors of 3 from the sequence given by the generator. So we'll have the from to generator going 0, 5, and the third function, and it will return 0, 3, and then undefined.
So you're asking if I call this sequentially 5 times, I should only get 0, a 3, or an undefined? Like those aren't the first 3 results I should get.
Those are the results.
If I call it 3 times, I should get those 3 results?
Right. Okay, let's look at filter. So did everybody figure out that you need to use a loop? Yeah, that was the key to this one. So, very good, we'll get to that. So here's one way to write filter. Well, first off, who got something that works? Okay, very good. So filter takes a generator and a predicate and returns a function which will stay in a loop calling the generator until it gets a value which is approved by the predicate, in which case it'll drop out and return the value. And that's an acceptable way to do it. Although in ES6, my most favorite new feature in ES6 is going to be tail recursion, or proper tail calls, which would let us write it like this. We're going to have a recursive function that I'm calling recur, and it will continue to call itself until the predicate becomes true. And so this is where it calls itself. And the reason why this needs a new feature in the language is that in ES6, the compiler is required to optimize that call. So instead of doing a call and then a return, it will do a jump back to the recur function, so that this function will run in the same time and same memory pressure as the earlier one. So at this point, there will no longer be an advantage to using loops over recursion. And that's great. So I'm really looking forward to that. Anybody else do a third approach or any other
I think there should be a way to use that compose function that we wrote earlier. Calling a function on a function. Well, we're not really calling a function on a function, but it feels like we are.
I used a while instead of a do while because I'm so used to Python that I forget that there are constructs.
Could you flip back to the ES5 version?
So he used while there. I actually think that we have too many looping statements. If it were just me, it would be loop, and that would be it. You know, loop bracket, and that's everything would happen in that. Yeah, because I find, well, I'm not using loops much anymore, but when I do, I tend to want to break out of the middle, and we've got loop syntax which says we'll break out of the top or we'll break out of the bottom, but that's not usually where I'm going. If I'm using a loop that is that disciplined, I probably don't need to use a loop at all. Anybody else? Okay, so should we go on to another one? Sure, why not? Okay, so let's do one more. This time we're going to concatenate a couple of functions together. So write a concat function that takes 2 generators and produces a generator that combines their sequences. So we're going to call concat, we're going to pass it a generator which is from to 0 to 3 and from to 0 to 2. And that will give us a new generator which will produce the sequence 0, 1, 2, 0, 1, and then undefined. So here's concat. It takes 2 generator functions. It has a variable to remember what the current generator function is. It returns a function which gets a value from the current generator. If the value is not undefined, it returns it. Otherwise, it replaces the current generator with the next generator and returns a value from that. So who got something that works? Very good. Anyone take a different approach?
Why not just return generator 2?
At the very end, why set generator 2 to generator 1 or to a temporary generator?
Because next year, when we have the ... thing, then I'll want to write it this way. Whereas I can take any number of generators, and I'm going to be using the element function that we wrote earlier to help me step through that array of generators. And I'll just load the next one in. So that's why. I didn't mean to show off, but that's why.
What is element gens?
Can I see the previous slide? I'm sorry. Why are you returning gen instead of value?
I'm returning the result of calling
Let's
gen.
call it.
I'm
When
calling
you say value is, I see value equals gen, and if that doesn't succeed, you're calling it again?
It changes it.
Gen 2.
I skip to the next generator
And
and then
this
call
one.
that generator.
At the very top, he's assigning gen 1 to that gen variable.
Right.
So that changes if the if doesn't succeed.
So first time through he calls gen 1. Second time through he calls gen 1. Third time through he calls gen 1. Still passing. Because it goes 0, 1, 2. Fourth time through he calls gen 1. He gets undefined. He sets gen to gen 2. Returns the result of gen 2.
Oh, you have a, okay. You had 2 returns. I wasn't expecting 2 returns. That's what I was mixed up.
Yeah,
You said value equals gen 2.
right. I could have done that business inside of the if. I could have reversed it.
Okay.
Yeah.
I got you now.
You're right. Do you think it would have been clearer doing it that way?
Well, I prefer to have 1 return than 2, I guess.
I'll think about that.
So in your next function,
The next is function, yeah.
what's element?
Element is a function we wrote this morning. You remember that?
It pops off the next,
Yeah.
it just pops.
It returns the next thing from an array.
Oh, not doesn't pop it, it pulls it, whatever. I don't have element.
You should. We did it twice.
Oh yeah, there it is.
Make a function gensimf that makes a function that generates symbols. So we're taking the generator idea and we're going to try to do something practical with it now. So gensimf is a symbol generator, or gensimf is a factory that makes symbol generators, or things that make serial numbers. So we designate a serial number with a prefix. So you can send it any string and that becomes the prefix string. And then we will get a series of strings starting with that symbol. So we're going to make 2 generators this time from the same factory. We're going to make the G series and the H series. And when we call them, we'll get G1, H1, G2, H2. Okay, let's look at gensimf. Gensimf takes a prefix string. It creates a number, which it's going to use for keeping track of where it is in the sequence. It will return a function which will add 1 to that number and return the result of concatenating the number to the prefix. So who got something that works? Good. Anyone do anything substantially different? Yeah.
I cast that prefix to a string in case you want to pass in a digit as that first thing.
That's a wise precaution. Yeah. Anybody else?
I use the from function.
Use the from function. That's great too. So this is an example. We've seen a number of these where we've got a factory function which then makes something which will do some work. Usually a generator, but it could be, there are lots of different kinds of functions. But they're both functions, it's just one is nested in the other. And in fact, if we nest further, if we put another function outside of this, we could make a factory. And you could wrap that with a factory. So just for fun, let's look at what this would look like if it were a factory. So gensimff is the factory. And we're going to pass the increment function and the initial seed value to gensimff, and it produces a function that works exactly like gensimf, and it'll make those sequences, right? And we've done things like this a couple of times already. So I'm just going to show you the thing because we've already done this one. So it looks very similar to patterns we've seen before where the factory is supplying values that go into the generator. And so we can automate the making of factories. Now, the interesting thing about this one is that statement there where we're creating the number variable, which is going to hold the value that is being used to generate the sequence numbers. So if we were to move that up one line so that it's not in the factory anymore, but it's in the factory, that would change the visibility of that variable so it would be seen by all of the generators. So instead of generating G1, H1, G2, H2, we would generate G1, H2, G3, H4. And that's a really interesting change in behavior. It's just moving one variable declaration one place to another. So, you know, we've been dealing with closure, and we saw that we can have things that are global and things that are local and things that are sort of in between, but there can be more of those in betweens. And if we get into nesting things in useful ways, we have tremendous control over the visibility and the lifetime of the variables and can do interesting things to affect their behavior. How about that? Any questions about that? Okay, ready for another one, or do you want to take a break? Let's do another one. Sure, why not? Okay, so everybody remembers Fibonacci, right? You did Fibonacci numbers in school. So Fibonacci was an important mathematician. He discovered a lot of good stuff, but the only thing we seem to remember is the Fibonacci sequence. And there are an infinite number of Fibonacci sequences, but mostly we only remember the famous one, which started with 0 and 1. And that's what we're going to be doing now. So we're going to make a factory which will make a Fibonacci generator. And you will seed the factory with the first two numbers in the sequence. So everybody remember how Fibonacci numbers work? Well, let's review. So the Fibonacci sequence will be a sequence of integers. You specify the first two integers in the sequence. The third number will be the sum of the first two. The fourth number will be the sum of the previous two, and so on. So the first numbers we get are 0 and 1 because those are the ones we provide. And then the next one will be 1 because that's the sum of 0 and 1. The next one will be 2 because it's the sum of 1 and 1. The next will be 3 because it's the sum of 1 and 2. The next will be 5 because it's the sum of 2 and 3. And the next in the series will be 8. Exactly. So this was a tricky one, wasn't it? I mean, the Fibonacci sequence itself is totally trivial, right? It's three simple statements, but getting the first two numbers to come out, that was the trick, right? So first off, who got something that works? Congratulations. This one was hard, right? So let's look at a number of approaches that we could take. So here's one. There's the Fibonacci function there in the box. So that's it. And then we've got an if statement around it, or a switch statement, which asks, where are we in the sequence? If we're at the beginning of the sequence, put out the first number, otherwise put out the second number, otherwise use the Fibonacci function and do that. And this works. This absolutely works. Or who took this approach, or something like it, maybe used an if instead, but basically, yeah, you've got a variable which is telling you where you are in the sequence. This is a completely, yeah?
Except for case 1, you're inputting A and B. A and B don't necessarily equal 0 and 1. If A is something other than 0 for case 1,
right?
You need to return A plus B, don't you?
No. So
maybe I don't know the rule.
He's switching on I.
I've got I, which is telling me where I am in the sequence.
I know.
Which isn't the value I meant the sequence, just how many numbers have I looked at.
I know.
So if I'm looking at the first number, I output A. If I'm looking at the second number, where I is 1, I output B. Otherwise, I output A plus B.
Oh, so if you want the Fibonacci, if your starting elements are 5 and 7, first number's 5, second number's 7, third number's 12.
Right.
Oh, okay.
Yeah, that's how they work.
Yeah, I was thinking that you added the first you took the second, then you added the first two. Then no, it's not until you get to the third.
It's the first two numbers, then you add.
Right, because they tell you Got it.
Is I incremented? I'm not getting it, I guess.
Well, yeah, well, instead of adding 1, I set it to 1 because I know it is 0. And beyond that, I don't need to increment it. Once I get past the first 2 cases, I don't care what I is anymore.
Oh, okay.
Okay, so completely acceptable. This is a reasonable way to do it. You know, I would argue that a reasonably intelligent person could figure out what this code is doing, and that's most of what we want code to do. So this is good. It's okay. My complaint with it is it's a fairly big function, and only that much of it is concerned with the Fibonacci thing. So it just feels kind of lopsided to me. So here's another approach. In this one, I kind of permuted the statements of the Fibonacci sequence in order to delay the output of the first, or to cause the first 2 numbers to get output. So who did something like this? Yeah. So this is probably the most optimal solution. You know, it's going to be the smallest code, fastest performance. Not that either of those matter in real life, but it does have that advantage. The disadvantage of this is I'd hate to be the guy who has to debug it, right?
I said B equals A plus next instead, but
Yeah. Yeah, there are variations on it, but you know, it's basically the same idea. So another approach we could take is recognizing that we're making a generator, and we already have some tools for constructing generators. So here's another approach. I've got my Fibonacci generator here, which will give me the next number. I just need to get the first 2 on top of it. So I'm going to make a special generator. And I'm going to start by taking identity f, which was the first interesting function that we wrote this morning that you thought had no practical application. It turns out what identity f is a constant generator. It will always produce the same value. Okay? So I'm going to use that to make generators. And then I'm going to use the limit function that we wrote earlier to cut off the sequence so I only get 1. So I got a pair of things, and I can then concatenate those 2 together and then concatenate that onto the Fibonacci function. So who did that? Of course, nobody would do that. And if you're, yeah, so there's that. And if I were going to be doing this a lot, I would take limit identity f and encapsulate that into something, you know, which would make sequences of 1 more compactly. Or we could do this. We could, a similar thing, we take the element function that we wrote earlier, make an array containing the first 2 things, and concatenate that onto the Fibonacci generator. So who did that? No. Very good. Brilliant. What do you say we do some object-oriented programming? Yeah. All right. Yeah. So we're gonna do something with an object now. We're going to write a counter function that returns an object containing 2 functions that implement an up-down counter, hiding the counter. So we'll call the counter factory and pass in an initial value, and it will return an object containing an up method and a down method. And when we call up, it will add 1 to the value and return it. When we call down, it will subtract 1 from the value and return it. And I'll give you a hint: no global variables, no this, no none of that crap.
We don't have that.
Darn it.
I always use global variables everywhere. That's what Ben taught me to do.
I did not teach you. What could go wrong?
Ben always says more globals.
It's exactly the opposite of that.
More globals.
So here is counter. It takes a value, it returns an object containing 2 functions. The first one, the up function, adds 1 to the value and returns it. The other one, the down function, subtracts 1 from the value and returns it. So who got something that works? Brilliant. If you didn't get it, write it down because you'll want to refer to this pattern later. So this is very similar to what we talked about yesterday, where we've got 2 functions inside of a closure which are both sharing common data. This is a very simple example of that, but basically all object constructors are going to follow this pattern. Any questions about this? Okay, want to do another one? So this next one, I promise, is going to sound much worse than it actually is, okay? So make a revocable function that takes a binary function and returns an object containing an invoke function that can invoke the binary function and a revoke function that disables the invoke function, okay? So let me explain what's actually going on here. This is something that might have some security properties, in that we might have some guest code that we allow into our system, and we want it to be able to run as long as we want it to, but at any point we want to be able to cut it off, and we don't want to have to rewrite our existing APIs in order to accommodate that. So this is a variation on the limit function that we wrote earlier. In fact, you might want to refer to your implementation of limit when you're doing this one. Except in this one, instead of keeping a count about how many times you get to do it, we will have a separate function called revoke, which will, when we call it, cause the thing to stop working. Okay, so we'll call our revocable factory, we'll pass in any existing function, in this case the add function, and it will return an object containing two functions. One of them will be the invoke function, which is the revocable add function, and we can give that function to the third party, but we will hold on to the revoke function for ourselves. And so the revocable add function will work just like add until we call the revoke function. At that point, all it does is return undefined. Everybody clear?
Some of those cases where you really need the ... arguments, isn't it?
Yeah, we want this to work for all functions, right?
Yeah. And right now it only works for
binary. And actually, anything that works for binary probably works for unary, because we're just going to pass undefined as the second argument, and it gets ignored.
So realistically, you could just plan ahead. And
yeah, if you knew we never use more than 10 parameters, you could do that. But
looks like
who wants to do that? Yeah, that's awful.
But you could call, if inside, you could always just call ours, right? You can pass that forever.
You can,
okay.
Yeah. So you can do that today. It's just inexcusably ugly, and I don't want to waste your time with it. So we're not going to do that.
Like argument 0, arguments 1, arguments 2, you can't just pass in the arguments object.
Oh.
Well, actually, you can, which is kind of a problem.
It didn't work for me, that's why I went that route. That was my go-to, is to try that, and then throw me something funny.
Oh, good. You probably did something wrong, which is great.
What's the
keep doing that.
Is it args or it's arguments?
Arguments.
So if you get arguments in a function and then you call another function inside of that passing arguments, you're passing an array to that function, and you're not passing each of the arguments in that array.
Right.
That's why it doesn't work.
But you could then use apply to spread it out.
In ES6? Or
in ES3.
Oh, okay.
Yeah.
Array.apply. It's a function. I'm sorry, not array. Arguments.apply.
No, unfortunately, it's function.apply. So we're not doing that. It's too awful.
That's right. You showed us yesterday, and you said it was ugly, so I ignored it.
Yeah, it was good that you ignored it. Okay, are we ready for revocable? So here's revocable. It takes a binary function. It returns an object containing an invoke method and a revoke method. The invoke method looks to see if a binary is undefined. If it isn't, then it will call it, passing the first and second argument. Otherwise, it doesn't do anything and returns undefined. The revoke function sets binary to undefined, thereby disabling the invoke function. So who got something that works? Very good. Anybody do something different? Something notable?
Nothing notable. I put a variable called OK, which I set to false, but it's the same thing.
That is okay, yeah.
Thanks. So I opened this up. So I created, we made this object, which is in the, and I look in the console at my object, and I want to introspect it. So I expand it. Well, where's binary in there? It's obvious. It's not exposed as publicly as a part of this object that's exposed, but it knows about it.
Right. Binary is hidden in the function scope of the revocable function and is available only through its closure.
Right.
And the only functions in the universe who have access to that closure are invoke and revoke. So that's why this is something that we can build secure systems out of. You know, if we were to take your OK flag and put it in the object itself, then the attacker could go to the object and turn it the other way.
Right.
So that wouldn't accomplish what we want to do here.
So they could obviously they could look at the source, but we've obfuscated that. I mean, it's,
Right. So we assume that the attacker can always look at the source, but they can look at this source and it doesn't help them, right? Unless they were there at the creation of the object, they can't get to it. They can't get to binary.
Right.
So revoke is irrevocable in this case.
That's right. This is a one-way trip. Now, we could design this to work a different way. You know, using his OK variable as an on-off switch, we could provide a second function or maybe an argument to revoke, which could reverse it. But generally, I prefer systems where once we cut them off, it's off, and we don't have to worry about something turning it back on again in an unexpected way. Yeah.
Since you're not explicitly returning undefined in the invoke, is this a case where you said you flip-flop on whether you should return undefined or not?
That's right.
Okay.
I mean, I like the idea of being explicit, and I also like not doing anything I don't have to do. And
Kind
so,
of at odds at each other.
Yeah, exactly. There's a real conflict there. But most of the time, doing the right thing and doing the right thing are obviously the same thing. This is one of the cases where it isn't so much. So this one's going to be totally trivial, so I'm just going to give you the solution. We're just going to do this because it's going to set up the next problem. Okay? So we're going to write a function m that takes a value and an optional source string and returns them as an object. And in this case, instead of simply passing things to the log, I'm going to be using json.stringify to make strings of the object, because it turns out object.toString is completely worthless. It doesn't show you anything about what's in the object. It's just, it's just not worth it. JSON.stringify, on the other hand, does a fairly good job of showing you what's in the object. So in this case, the stringification of m of 1 is an object where the value is 1 and the source is the string 1. We make the string of the value. If we pass in a second argument, then that second argument will be the source property. So if we pass in pi and the word pi, the value will be pi and the source will be pi. So this is the function, the constructor that does that. So go ahead and type this in. I'll give you a minute, and then we'll go on and we'll do the next problem. Write a function addM that adds two m objects and returns an m object. So you can imagine we could have a regulatory requirement that not only do we provide results, we also provide extreme detail on how we obtained the results. So this is a way to help automate that. So if I add two m objects, I get an object where the value is the sum of the values, and the source is the concatenation of the two values, or of the two sources, with a plus sign and parens around them. So if we add m3 and m4, the source will be paren 3 plus 4 closed paren. And a similar thing happening with pi. Okay, so here is addM. addM takes two m objects. It returns a new m object where the value will be the sum of the two values and the string, or the source will be the concatenation of the sources. So who got something that works? Did anybody do it the hard way? Yeah. First rule of object-oriented programming. Let the objects do the work. We already have a nice constructor, and we want to use it because there's a chance that we might change what m does, and so we want all of the instances to take advantage of that. So if you didn't get this one, write it down because we're going to need it for the next one. Okay, are we ready? So write a function liftM that takes a binary function and a string and returns a function that acts on M objects. So we've done this before, right? If we pass the add function to liftM and also the plus string, it will make a function that works exactly like addM. And we can do the same thing passing multiply and asterisk or any binary function. So this will help us to automate the process of building this system of journaling arithmetic.
Do you need to do the check on the source whether it's string or...
No, if we try to concatenate it with the strings, it'll be coerced to be a string.
Can you show the problem again?
Okay, here's liftM. liftM takes a binary function and an op string. It returns a function that takes A and B. It returns a new M object where the value will be the result of the binary function on the two values, and the source will be the concatenation of the sources of the op string. So who got liftM? Way to go. So if any of you ever heard of monads, the Haskell guys talk about them all the time. You just made a monad. So you can go home and tell your kids, made a monad today. You did that. All right.
So what is a monad? A monad is?
So a monad is a thing where you can take functions and lift them up to a higher level where they can have or acquire some new capability. The Haskell community uses them because there's a trap in Haskell. Haskell is a brilliantly designed language, and one of the characteristics about it is it does not allow any kind of mutation. So all functions are pure functions in the mathematical sense, and that's a really interesting thing. Except that if your programs have to interact with the real world is constantly mutating, right? And something like an account balance cannot be a constant, right? It's got to vary. And they can't even do I/O in an immutable system, right? You can't have anything coming in, you can't have anything going out because nothing can ever change. So that kind of made things practically real hard for them. And they figured out this trick with monads, which by using higher order functions in really clever ways, they can have the appearance of mutation without actually mutating anything. But that's for another time. Anyway, you made one of those, so congratulations. So if you didn't get this function, you should have it now because we're going to use it again in just a second. So is everybody ready to move on? Okay, so here's the next problem. Modify function liftM so that the functions it produces can accept arguments that are either numbers or M objects. So to make this a little bit easier to use, you can pass in any number. You don't have to explicitly wrap it with M first. So we'll just change liftM to do that. Okay? And make it really flexible so that you can pass in a number or an M object or two M objects or two numbers. Any combination will work.
Either 2, 3, or 4 arguments, or?
No, it'll take two arguments.
One, it's either an M or
a number.
Or a number. Okay.
Okay, here's liftM. So the change I made was in the box. I just looked at the type of the argument, and if it is a number, I'd call M to turn it into an M object. So who got something that works? Very good. Who did it the hard way?
What's the hard way?
Where you didn't do that. Yeah. So first rule of objects. Write a function exp that evaluates simple array expressions. A simple array expression is an array in which the first element is a function and the remaining elements are the arguments to that function. So if we pass that array mul511 to the exp function, it will return 55. And if we simply pass a number to the exp function, it'll just return that number. Okay?
We expect a binary.
Yeah, but assume a binary function. It turns out it will also work with unary functions. But
What's EX? Oh, we're writing EXP, sorry.
yeah, you're writing it.
And it's always 3 elements in the array?
It could be 2 or 3. But,
2 or 3, okay.
but you don't care about that. Assume 3. It's always 3.
Sure.
Interpreter.
Next year it'll be n, but
Right,
this year
okay.
it'll be 3.
Makes it, it's done.
Okay, here is exp. exp takes a value and it returns something. If the value is an array, it returns a result of calling the first element, passing the next 2 elements as arguments. Otherwise, it returns the value. So who got something that works? Very good. Want to do one more? You think you got it in you? It's going to be based on this one. So if anybody didn't get this one, get it now because you're going to need it. Okay, ready? Last problem. Finish strong, okay? So modify exp to evaluate nested array expressions. A nested array expression is just like the simple array expressions, except any of the arguments can also be a nested array expression. So in this case, we've got a hypotenuse thing going on here. And if we pass that nested array structure to exp, it will now evaluate the whole thing and come up with 5. Okay, everybody got it?
Any one of the parameters is an array, then that has to get passed off to, that gets evaluated.
Yes.
Okay.
Exactly. So let's take a look at exp. So the only change that I made was I called exp on each of the arguments before we used them. That's it. And so recursion ends up doing all the work, which is really, really nice. Anytime you're dealing with nested data structures, recursion is usually the ideal way to deal with that. So one of the nice things that this function illustrates is just how powerful object systems or function systems can be. That this little function, and it is a little function, implements most of a programming language. Anyone recognize what language this is? Lisp, yeah. In Lisp, they use parens instead of brackets, and the commas are optional. Otherwise, this is Lisp. You know, it's clearly not the whole language, but it's an interesting part of the language. And one of the reasons why people who do Lisp act the way they do is because they can do stuff like this really, really fast, really, really easily. That's just, you know, you compare that to implementing a system to do one of our languages, and it's just a completely different thing. So I hope you all enjoyed this. Today was grueling, but you came out. Does anybody feel like their brain got bigger today? Anyone feeling that? So before I send you home, obviously you're going to need some homework, right? So let's get to the homework. The homework problem is write a function add g that adds for many invocations until it sees an empty invocation. You know when you get an empty invocation when you receive undefined as an argument. So in this case, if you pass nothing to add g, it'll return undefined. If you pass 2 and then nothing, it'll return 2. If you pass 2 and then 7 and then nothing, it'll return 9. If you pass 3 and then 0 and then 4 and then nothing, it'll return 7. And if you pass 1 and then 2 and then 4 and then 8 and then nothing, it'll return 15. So I'll give you a hint. This problem is going to involve a function returning itself, which is something you may have never encountered before. Okay, let's look at add g. Add g takes a first argument. It creates a more function. If the first argument is not undefined, it returns the more function. The more function takes the next argument. If the next argument is undefined, it returns first. Otherwise, it adds next to first and returns itself. By returning itself, it allows for the next thing to happen. And I call this recursion. Now, recursion is when you have a function that calls itself. Recursion is when you have a function that returns itself. So anybody do anything else, take a different approach to solving this? There are lots of possible solutions.
Yes. You're doing the same thing where you compute ahead the next value. That you did another one yesterday.
So if you didn't get this one, please write it down because you're going to need it for the next one. Anybody else?
Well, it's a different one. I don't know how to read it. I'll say it. I had, if X is undefined, return undefined. I don't know. I don't want to say it. I just, never mind. Keep going.
All right. So I'll give you a minute to capture this. So while that's happening, can anyone guess the name of the next function that we should write?
Add MG. Lift G. Lift
Yeah, very, very good.
Yeah.
Lift G, of course. What else would you want to write next? Write a function lift G that will take a binary function and apply it to many invocations. So it's similar to what we've done before. If you pass the add function to lift G, it gives you the add G function. We could do the same thing with multiply and make the mul G function.
If you passed add into lift G, what would the value of the first operation be? What would you get back from the first time you call?
Undefined.
It would be undefined.
Well, if you were to call the result
No, instead of passing in mul, you pass in add.
Right. Oh, then so you'll get undefined, you'll get
And then the
3,
next one,
and then you'll get 7.
you get
And
3,
then you'll get
so you
15.
add 3 to 0.
Yeah.
But with mul, you're multiplying 3 times 1. Okay.
All right, so here is lift G. Lift G returns a function. That function gets the first argument. If first is undefined, it returns first. Otherwise, it returns the more function. The more function gets the next argument. If next is undefined, it returns first. Otherwise, it sets first to the result of the binary function with first and next and returns itself. So who got something that works? Outstanding. Very, very good. Any questions about this one? Anybody do a different approach that they think is worth mentioning?
I didn't get it to work, but I tried to do type of first as object, and then I would do something. Just trying to figure out if it's a function or a number.
All right, so if you didn't get this one, get it down. You might want to refer to it in the next one.
I just inserted the add G function inside the new function and generalized the add G function.
So the first time, if you call this with nothing, then if you pass in undefined, you
Right.
just get back itself.
Right, we return undefined. So
So the next time if you pass in a number,
that number is now first. And then the second time, if we get undefined, we return first.
the number is now first. Oh, I see. Yeah, great.
Write a function array G that will build an array from many invocations. So if we call array G and pass it nothing, it returns an empty array. If we pass it 3 and then nothing, it returns the array containing 3. If we pass it 3 and then 4 and then 5 and nothing, it returns 3, 4, and 5. Okay, so here is array G. Array G takes a first argument, it creates an array, it makes a more function, and it returns the result of calling the more function with the first argument. The more function gets the next argument. If next is undefined, it returns the array. Otherwise, it pushes the next argument onto the array and returns itself. So who got something that works? Very good, very good. Did anybody try using lift G? Anyone? That would have been extra credit. All right. So, let's do another one. Okay, this is a good one for you. Make a function continuewise that takes a unary function and returns a function that takes a callback and an argument. There's a style of programming called continuation passing style, in which functions, instead of returning values, instead are given an additional argument, which is the function to which to deliver that value. And in continuation passing style, computation is always going forward. Functions tend not to return anything. They're always going forward, and it's amazing. And when JavaScript gets tail recursion with ES6, then we'll be able to do that in JavaScript, and that'll be great. So this function is intended to help us to migrate toward that style of programming. So what it'll do is allow us to take any existing unary function and turn it into a function that will take a callback. So in this case, we're going to pass the square root function to continuewise. It will return the square root with a callback function. We will then call that function, passing in a function that will receive the result. In this case, I'm suggesting that it could be the alert function, which is something that lives in the browser, which will pop up a box and show you the answer. If you're not running in a browser, you could log to the console or whatever you're doing, just some way of seeing where the result is going to go. And then we'll pass in 81, which is the number we want to take the square root of. So if this function is working correctly, then we should see a box show up on the browser with the number 9 in it. Okay, so here's continuewise. Continuewise takes a unary function. It returns a function that takes a callback and an argument, and returns the result of calling the callback function with the result of the unary function and the argument. So who got something that works? Congratulations. You are now in the 90th percentile of JavaScript programmers. Not that the bar was ever very high, but you're up there. And it's because you understand an aspect of the language which is really, really important and vitally important that most of the people working this language don't know that it's even there. And it's really important that what we've been doing over the last day is a paradigm shift. I could talk for hours and hours about what could happen when you have a function that returns a function, and you would think you would understand those words and go, yeah, but unless you've done it a few dozen times, it really won't make any difference. It won't make any sense. But you've done it now. When you came in here yesterday morning, you did not know how to write this function, and you just knocked it off. You wrote it very quickly, and you got it right. So, good for you. And the reason we went through all of this is that I wanted to explain to you again something that I did on the first day that you thought you understood, but you didn't. So we're going to go through that again now. And this time, you now have the tools, the context, in order to understand what I was talking about. Pattern for using functions to construct objects. And I've got my constructor function. I've passed in my initialization object. I'm calling another constructor, which allows me to inherit what that thing does. And I'm going to add stuff to that, or that will be the object that I'm constructing. I will create my member variables, which are the things that my methods will have access to. That's where I'm going to be keeping all of the state, all of the data that's within this object. I will create my member methods, which are just local functions within this scope. And each of these will close over the initialization value that we pass in, whatever that is. I recommend an object, over all of the other members and over all of the other methods, so that we don't ever use this in this pattern. And then anything which needs to be public, I publish it by assigning it to the outgoing object, and when I'm done, I return the outgoing object. So I'll have as many members as I want, as many methods as I want. I make as many of them public as I need to, and then I'm done. It's a really straightforward way of making objects. It's very flexible. There are lots and lots of variations on this, but this is the basic pattern that I recommend for using for constructing objects in JavaScript. Now, next year, when all of ES6 becomes available, and there's some new syntax in ES6 which can be applied toward this, and also with an eye on making our systems even more secure, I'm going to revise the pattern to be like this. So this is next year's pattern. I'm going to start with a constructor object as before, which will contain, lots of good stuff which tells me how to make the object. Then I'm going to make my instance variables. And I'm using some new syntax here. First off, I'm using the let statement. In this case, there's no advantage to using let over var, but it makes the Java guys happier. So I'm going to try to use let as we move to the new language. And the curly braces around the variable name mean something special here. So what I'm doing is I'm creating a new variable called member, and I'm going to initialize it with spec.member. So it's a shorthand for doing those sorts of things. And I can put as many names in the curly braces as I want, separated by commas, and each of those names will be initialized by a similarly named property from that object. So this doesn't let us do anything that we couldn't do before, but it's some convenient syntax for pulling values out of the initialization object and putting them into our local variables.
So when you say let brackets member equals spec, now spec.member is
the initialization
initialized.
value, is the initialization value for the member variable. So that statement means the same thing as let member equals spec.member.
It's member equals spec.member. Okay.
Okay. Okay. Then I'm going to use the new const statement to, in a similar way, I'm going to this other constructor where I'm going to get methods which I'm going to be using, and I'm going to extract the methods that I want to use and put them into private variables. And I'm doing that because I anticipate that this object could be frozen, and so I don't want to be adding stuff to it as I was in the previous model, because I don't want to break if someone that I'm trying to inherit from passes me a frozen object. This also solves what's sometimes called the banana problem, that there's a complaint about object systems where you want to inherit a banana, but you end up also inheriting the gorilla that's holding the banana and the jungle that the gorilla is in. You get all of this stuff, and all you wanted was this little thing. So this allows us to do that. We can extract things that we want. And because we're extracting things now, we can call as many of these guys as we want. So we can get to as many of these other constructors and take all of their goodness and pull it out into local variables, and we get all that goodness. Then again, I'm going to be making my methods, and again, my methods will close over all of this stuff, and again, my methods are not using this. Then when I'm done, I publish the public methods here, the ones that I made or the ones that I inherited, and I'm taking advantage of new object literal syntax here, that if you have an object literal and you just say a name and you leave out the colon, it's a shorthand for name colon name. So this is short for method colon method, and that's short for other colon other. Again, not essential, but it's nice, and it gives us this starts to look more like a declaration than like code, where I'm just giving the list of things that I want to publish. Then finally, I'm going to freeze that object, because freezing gives us very good security and reliability properties for objects, which we can't get in this language in any other way. So when we look at the evolution of programming, in languages like C and Pascal, we got structs and records, data structures which let you have named properties. And then in object-oriented programming, we took it a step further, where we could have functions or methods which are related to those structures which will act upon them. And I think that was a really important evolutionary step, but it shouldn't have been the last step. So I think JavaScript actually gives us a way to go forward from this, so that I'm now thinking that we have two very distinct kinds of objects. We have objects which just contain data, only data, and objects contain only functions which are frozen. And those objects are very strong, very reliable, they cannot be tampered with. They provide the interface for dealing with the objects which are containing the data. And that way we can create good APIs which can defend themselves, which can remain robust in the face of all the confusion that's happening inside of our system.
So how would you pair those two things, the data object
Well,
and...
I'm going to put the data in the member variables. All of the data goes in the member variables. And those could contain simple values like numbers and strings. They could contain objects. So, any other questions about that?
I don't understand any of this.
Yeah, we'll review it again this afternoon. So, what I want to do now, do we need a break, or are we ready to go into the next problem?
Can I just ask a question for clarity's sake? So when you're going to use that pattern, you'll have your function object, you'll have your data object that you'll feed your data into, and you'll feed your data object into the function object, act on that function object, creating a new data object to then act on the next in the chain of function objects that are all the function objects never change or immutable, but they all create new data sets to be
Right,
used?
each time we call this constructor, we'll get a new thing.
Yep.
And within its function scope, it'll close over, whatever objects you need to work on.
But it itself and its data that when it's created is all immutable, and it's going to give you new information out of it.
Well, the data is mutable, but only within the function scope. It is not, you cannot mutate it from outside except through the function.
So freeze doesn't mean that it can't change its own data if you act on the functions.
Right,
You just
freeze
can't give it new input.
Freeze is only on the object containing the functions. The functions themselves are still free to act on anything that they close over.
Okay.
Could you go
just
back?
can't change what they do.
Could you go back to the previous slide, please? And it could be 5, and it could be
That's
an
whatever.
object. It could be anything you want.
It's anything you want to pass to a constructor.
I think I'm confused by the fact that what does the other constructor do? It creates yet another object that.
Right, it provides a means of inheriting something else. This is how you would do inheritance in this pattern. If you don't need to inherit from something else, then we'll just start with that being an empty object.
Right. Or it could be some values that get assigned.
Whatever, yeah.
I don't understand how this is related to what you congratulated us for doing something 5 minutes ago that I've been doing that with Node for a year, and this still doesn't make any sense to. I mean, this makes sense to me. I don't understand the relationship. What we were passing a function in.
The relationship is this is only possible if you understand how to use closure and function scope.
Yeah.
Which is something you can do now.
Right.
Here's the next problem. This one's going to be a little bit different in that we're going to do it all together. Okay, so we're going to make an array wrapper object with methods get, store, and append such that an attacker cannot get access to the private array. So the idea is that we've got an array and we want to protect it behind a good API. And we want to be able to hand it to a third party, even a malicious third party that might want to get directly to the array, which we want to prevent. So this is how we would do it, we've got our vector constructor, which will make a vector instance, and it will have an append method, which can be used to append things onto that secret array. It'll have a store method, which will allow you to store things into that array, and it will have a get method, which will allow you to retrieve things from that array. Okay? So think about how you might implement something like that. I'm going to guess, based on what we've been doing, it might look something like this. So here's a function called vector. We have an array variable containing the array. That's the secret that we want to protect, and it's hidden in the function scope, so we're already off to a good start. And we're going to return an object containing 3 functions: the get function, store function, and append function. The get function will take I and return array sub I. The store function will take I and V and store into I the V value. And append will take a value and push that value onto the array. So the guarantee that we want to make is that we can give this to a third party. The third party can access the array indirectly using these methods, but the third party cannot get direct access to the array itself, because we want to limit access to the array to only the things that we can do and not to any of the other things that you could do to an array. Now, it turns out there is a vulnerability in JavaScript which invalidates that guarantee, that it is possible for a determined hacker to get direct access to the array. Now, this problem has been shown to some of the top JavaScript experts in the world, and they could not see the attack. The attack is not something that's due to bugs in implementations, so we're only concerned with standard behavior of the language. There are some things about the language which we know are problematic. For example, you can go to array.prototype and replace its push method with your own method, or we'll assume that those things have been fixed. So we're just concerned with the language as it works, as we've discussed. So your job will be to figure out this code and suggest how the code could be attacked and how an attacker could get access to the array, and then how we would repair it so that the attacker couldn't do that. And my job will be to honestly answer all of your questions about how this code works, and there you are. Okay?
So the goal is to protect array.
Right. Which we have started to do. We've got the thing in a function scope. We've got methods that close over it. We've done all of that stuff well, but there is a vulnerability in the language which will frustrate our work.
I mean, can't you just... And you just have the return object, right? So you could make a new... Could you potentially define a new key with a function that just returns array? Or
So
you just...
How would you do that?
Yeah.
Call store. Store function.
So be more explicit.
So you call vector.store and you pass in the function that returns the array.
Okay, but the function you pass in is created on the outside, right? So that function doesn't close over the array when it's on the outside. And so only functions created on the inside will be part of that closure.
Add a method to the function prototype.
It is possible to add functions to the prototypes of system objects, and that is definitely a thing to be concerned about. We're assuming that's been fixed.
So if you were to, I think this is what John was saying. If you were to, you instantiate a vector, and then you say vector get array equals function return array. Like, array is undefined because it's in that scope of where you're creating it.
That's right. So that's good. That's a place where
That's
the language
protection.
is working for us.
Yeah.
Yeah. That's not where the language is weak.
If you inherit from vector, could you have access to the array?
That's a really good question. No, because function scopes don't work like Java scopes. You know, there's no package kind of thing, so no, you don't inherit the contents of a function scope.
Can you twiddle with that function? So vector, your instance.get has this function in it. Can you, it is a function. Can you, is there some way to manipulate the guts of that function once you have a pointer to it?
No. No, functions,
Okay.
yeah. Like you could store a function, you could use store to put a function into the array and then use get to get it back out. But the function is not altered as a result of that experience. It doesn't remember that it's
Right,
been
the
stored
function
in the
doesn't have
array.
any properties that you can go and pick at
Right.
or change, so that when you call it the next time, it gives you something completely different.
Right.
If I tack a function onto that and call this, does this have access to array?
You are onto something.
So if I added a function called screw it up, and screw it up said this dot array equals a new array,
It wouldn't be this dot array because there's not an object which represents the contents of the scope. But this is definitely part of the attack.
Can we change push so that we said array, we changed what the prototypical push of an array does so that it returns its own value?
Yeah. Yeah, you are getting close.
Okay. Oh, because return I, or that, the third function doesn't return anything, so that's not going to get it out. The second one doesn't return anything, so that's not going to get it out. Or actually, but if you pass in an array to store, you could change, or no, you could pass in an array to append and change push so that what push does, it takes the thing that you've passed in and pushes onto the end of it itself. So you call append with this array, and then you get the last thing off of the array, and that's the array you want.
No, that didn't work. You're drifting away. You almost had it. You were very, very close.
Push a function on the end of the array using append, and then you use get to call that function. So
You can do that, but the function does not remember that happened. So it is not altered by that.
gotcha. Yeah.
How do you, in JavaScript, change the function of a prototype? Would you take like array.prototype.push? And now you're manipulating, okay, there it
That's
is.
exactly it. Yeah, you could go to array.prototype.push, but we're assuming that that's been fixed. That, so one of the aspects of the design of JavaScript is that everything is unlocked with its guts exposed. And if you're thinking about security, that's obviously a terrible thing. So we're assuming that that's been fixed. So we're concerned now just with the performance of ordinary programs.
So if you were to store a function that calls this dot array, you still wouldn't have access to the internal, right?
This dot array won't get you there, but this itself will get you there.
So it just returns this.
Yes.
Yeah, I got it. It was what I described exactly did it. What I did, I wrote array.prototype.push equals function on A bracket 0 equals this. So then I created an array, 1, 2, 3, 4.
Right?
And I created an array X, empty array. And then I called my first array dot push passing in X. It took that empty array, took the array itself, made that the first element of X that I passed into it, and now X, the first element of X, is the array I wanted to hack out.
Right, but I've said a couple times, we're not looking for array.prototype. That we're assuming that that's been fixed.
Oh, I'm sorry. Array.prototype is fixed in the new version of the language.
Well, no, we're assuming in the context of this problem that that's been fixed because of the very thing that you just described.
Has something to do with using the call method?
It is not, does not require use of the call method. So you've gotten very close a couple of times. It is concerned with push. It is concerned with a function that will return this.
So, return this, or uses this, it's referring to the array, or is it referring to vector?
The array.
So we bind a new function to this?
Through the length of the, you can loop through the length of,
No.
If you push a function onto the, if you append a function onto the end of this, you call that, it's the wrong scope. Does it involve passing a function into one of these?
Yes, it does.
If that function includes this inside of it, and then you call that function, what will the scope of this there be?
It will depend on how the function is called. Remember that there are 4 different ways to call a function, and what happens to this depends on which form of call it is.
So we want it to be,
You want it to be the method form.
what's that look like?
It looks like a method invocation.
Okay.
so the function could assign this to a global variable.
It could.
Okay, outside of the function.
Right, that's not, in fact, that is a possible way of exploiting this. But it's not key to the attack.
Okay, so I pushed onto the end of the function, which console logs this 0, and it's putting the first element of the array into the console.
Right, but they can get the first element of the array simply by calling push.
So we want the whole array.
Not necessarily the whole contents of the array, but the array object itself. That's the thing that we're trying to protect.
Right. So I pass in okay, got it.
You call this dot array from a function that you pass in and you store into the array?
I don't think that's going to do anything.
Poking around in the constructor, am I in the right path at all?
I'm sorry?
If I say this dot constructor,
That's not going to help you. This by itself, if you can get it bound correctly, is what you need.
So I don't have this bound correctly, but I passed in a function that returned a console log this, bound that via get to a variable, and then called the variable, and that's returning the window object. So I don't know if that's
Yeah.
getting on the right track or not, but
No, it's not. I mean,
No,
you,
okay.
you can get to the window object without calling anything.
Thanks, Douglas. So all I did was push a function on it, returns this.
Mhm.
And so now, I guess I need to know how many items are, now I'm looking at this function here. I guess I need to know how many items are on it. So now I have to actually use store, it looks like.
Right.
So I'm going to store at a position, say 5, function that returns this. Now all I have to call is get 5 parents. And the result of that's going to be the array.
No, it's not, but you're getting closer. You do want to store your function.
Okay.
So the thing you haven't got yet is the value of I.
We never gotten the value of I.
Yeah. There is a specific value of I that makes this attack work.
Oh.
Undefined?
Nope.
-1?
No. What'll happen if you say -1?
I have no idea.
Well, it'll take the brackets, right? The brackets will say, oh, take that number, turn it into a string. So you get the string,
-1.
-1, and it will then store it at array dot -1. That's where it goes.
JavaScript objects don't fill in if you set a really high number, do they?
Nope.
It just because they're not really arrays.
They're really hash tables.
Yeah.
What's to do with the max number? What's that number?
No.
You're trying to store current length plus 1.
But you don't know the length.
No, you're right, okay.
In fact, for this attack, the length doesn't matter.
Okay.
So is I where we want to pass in this to refer to the array object?
I'm sorry?
Is I where we want to pass in this to refer to the array object?
No, you want the reference to this to be in the function that you pass in as v.
I don't know, it seems to me that you could, first of all, you have to know that this vector that it's an array that you're dealing with, I would think.
Right?
If you
Yeah, we'll assume that the attacker sees the source
you
code.
set an arbitrary value, then you're obliterating that arbitrary value. So let's just choose a random number 5. First you've got to get 5. So now you've got that. Now you can set 5 to this function that returns the whole array.
Right?
And then you need to fix 5 in that array with the one that you got the first time.
Right?
And now you've got the array.
But you don't.
Don't.
No, because in order for the binding of this to happen, you have to call it as a method in this context.
Yeah, I mean, I'm just playing in the console window here. Okay. Yeah. I'm sure I'm obviously doing something wrong. Sorry. Act like I pretend like I know what you in here.
Right.
So there's a specific value of I where you need to store this function.
Yes.
Okay.
You trying to get to throw an exception, maybe?
Nope. So are you stumped?
So it's not undefined, you said, so...
It's not undefined.
No?
No.
So like one.
It's not null, it's not 1.
Can you pass one of the array functions like map?
You can, but that's not going to help you.
0?
It's not 0.
There's a magic number. Hey, come on.
Is it 22?
Is it like vector.prototype or something?
Nope.
And it's not some weird magic number.
It's not a weird magic number.
42.
That's high, but that gets converted
In
to
fact,
string.
it's not even a number.
Is it not a number?
It is not a number.
It's a number!
But not a number is a number.
So it is not a number? Like NaN?
No, it's not.
No.
Man.
It's not man.
Man, okay.
How about function?
I say we just go for it. What do you guys think?
You gonna make him tell us? You guys are
furious hacking over there.
I cannot
Well, we have
stand
two
to have
hackers.
people give up the answer before we solve it. But we could be here all day.
What does
We're
chat
just-
say?
Somebody Google it. And we can pretend like we got it.
That's on Stack Overflow.
Yeah.
Is eval at play anywhere in the mix?
No, we are not using eval. That's a really good question. Eval is full of trouble, but we're not concerned about eval here.
Is it a string?
It is a string.
Is it for each?
Nope.
Is it the empty string?
It is not the empty string.
Get this.
Two strings.
The string
It
this.
is not two string.
I don't know.
And it's not the string this.
It is not the string of this.
I try to push it. This is a key. This is a value. Either way, it doesn't work.
Is it every?
It is not every.
Not the string
Is it the name of
array.
a function that you can call on an array?
Yes.
Well, okay, is it constructor copy within and you choose every field? Those are fine, fine.
Yes, it is one of those.
Okay.
So it has to be an array method.
Oh, it's push.
It is push.
So you set, so
Right, so we
store push.
store push with a function that has access to this. So then the question is, how do you get that function to get called?
Call append.
You call append. Ladies and gentlemen. So let's look at the attack that he just outlined. So we've got a global variable. I'm calling it stash. Someone suggested a global variable, and there it is. Then we will store into push a function which will take this and store it in that global variable. And then in order to get this function to be executed, you call append. Append will call the push, and because this is a method invocation, this will be bound to the array. So this attack exploits several confusions that are in this language. The principal confusion is there are not arrays in this language. They don't behave like arrays in other languages, but we think that we do. And even the people who build JavaScript engines, when they were shown this problem, they know how arrays in JavaScript work, at least better than anybody. And they couldn't see it because everybody thinks this is what arrays do. So when you have this I here, even though we know we don't have ints in this language, everybody thinks it's an int, right? So it doesn't occur to anybody that this could be anything else. But it's just a key, right? In fact, what JavaScript will do is it'll take whatever you pass in. If it's not a string here, it'll turn it into a string. And that's what JavaScript does, but that's not how we think a programming language should behave, right? And when you have a system that does something other than what we expect, you get confusion, and confusion can lead to security exploits, as in this case. The other source of this problem is that all variable bindings in the language are static, because function scope, if array is defined there, then this one will be bound to that one. It's predictable with the exception of this. This is bound dynamically. And so it's much harder to reason about what the value of this is going to be at any instant because it can be different depending on where it's called and when it's called. And that turns out, if you're thinking about the security of systems or the reliability of systems, to be a bad thing. That's why I prefer to try to figure out ways of programming in this language that don't depend on this, since this tends to be unreliable. So what you think of that problem? Was that interesting? So now that you understand the attack, how would you correct this code to prevent that attack from happening? Yeah.
Just to give credit, Vincent in the chat room, I think he had got this just a little bit before we did. But then he's saying to fix it, he would just force the I to an int, like plus I.
That's exactly right. I would do that too. So I would put a plus I here. What that accomplishes is plus will turn the string into a number. If you pass in a number, it just stays a number, so it's a no-op. But if you pass in the word push, it will turn it into a number. What number does push turn into? Nan. And so then turn nan into a string. So we'll be storing v at array.nan, which is stupid, but at least it's not push, right? So we get around that. The other thing we could do is not use push, instead use the old-fashioned way of assigning to the current length. This illustrates another design error in the language, that I think something as fundamental as appending to an array should be an operator. It should be something that's just built into the language which can't be corrupted, but it's not. JavaScript allows, and there's also the weird way about how these get bound. So ordinarily you would, when you call a push method, you're going to be using the inherited array.prototype.push. But when we assigned our own push property to this object using store, now push is local, and so we don't look at array.prototype.push. And that, again, doesn't match most people's mindset about how a programming language should work. That's probably not the kind of behavior that you want this function to be able to modify. So what'd you think of that problem? Was that fun? Was that interesting?
Yeah,
Yeah.
why not just give JavaScript real arrays? Would it break it? Or?
Oh, absolutely break it. Yeah, there's code all over the internet that assumes this terrible behavior.
And you can't just say that ECMA 6 is a new standard that has a new...
I wish. The web is unlike any other platform in that, like if you're developing a server, you dictate what software is installed on that at what revision level and so on. You've got control over everything happening on the server, so you can dictate that stuff. And so you can tolerate breaking changes because you decide when you're going to make the change. But on the web, you have to run with whatever it is that someone's got installed. And if they're running some awful old thing, your code is still expected to run on that old thing.
So for ECMA 6, they're going to have new... I'm sorry, I'm not a computer scientist. They're going to have new stuff that can eat ECMA 6, right?
Right.
So why not create a new thing instead of an array? Call it a list.
They could do that. In fact, they have added new things in ES6. For example, there's a new thing called a map, which behaves like objects should behave. It is more correctly like a hash table. And there are new forms for doing that, but it doesn't look like this, and so it's going to be very difficult to get people to use it because it doesn't have the syntactic conveniences that this one has. Yeah, so
I know there are good answers for these things.
I'm not trying to wave it off. I mean, the web is once we make a mistake in a web standard, we're stuck with it. And all we can do is pile more mistakes on top of it. We can't correct any of the stuff that's ever been done. And so working with web standards, as you all know, is incredibly frustrating because nothing ever gets better. It just gets bigger.
They did get rid of the blink tag.
Well, not entirely. I mean, you can still write blink,
I know.
and it's not going to give you headaches anymore, but it's still allowed. It's still building structures in the DOM. It's still there. And in fact, you can write CSS, which will cause the blink to come back to life. So it's
Yeah, people have written JavaScript plugins and CSS, you know, that are
Bring back
Bring
our
the-
GeoCities page.
bring back the blink.
yeah, it's very, very hard to fix the web. Because when something wrong happens, the problem with the wrong things isn't that they're useless, it's that they're dangerous and weird. And there are very clever people who will go, wow, that's crappy, what can I do with that? And they'll figure it out. You know, and they'll take the stupidest thing you ever saw, and it now becomes part of some popular library, and we can't get rid of it anymore. So this is a problem similar to the first one. We're going to make a function that makes a publish subscribe object, and it will reliably deliver all publications to all subscribers in the right order. So the idea is that we might have multiple parties running in our system, and they need to be able to communicate with each other, and we will provide them a pubsub instance that they will all share that allows them to communicate. But we want to make sure that it works correctly, you know, so that it can reliably deliver all the messages to everybody in the right order. So this is how it might work. We'll have our pubsub constructor, which will make a pubsub instance, which we then share with all the parties. It will have a subscribe method on it, which can receive a function, which will be called whenever somebody publishes. And it can publish by calling the publish method, which will then cause all of the subscribers to get called. Okay, so you can imagine how you might implement something like that. It's not very complicated. Here is a possible implementation. We've got a pubsub constructor. It has an array of subscribers where it's going to keep the list of subscribers. It will return an object containing two methods. First, the subscribe method will receive a subscriber and push it onto the subscribers list. And the publish method will loop through all of the subscribers and call each one and give them the message. Okay? So it looks pretty straightforward. And unfortunately, it doesn't do any of the things that we need to guarantee. It is possible to prevent people from publishing and subscribing. It's possible to remove subscribers and cause messages to get delivered out of order, suppress messages. Everything that this is supposed to prevent, it will allow. So your job is to figure out how an attacker can do this. So if an attacker is one of the subscribers and wants to screw it up for all of the other subscribers, how does he do that?
Could you use the attack from before and empty out the subscribers array?
That is something to be concerned about. We don't have a store method this time. So we don't provide a way of changing the push property of the subscribers array. But that's definitely something you want to be thinking about.
Push a function though. That's
Yeah.
called publish, right?
I'm sorry?
You can push a function called publish. Something. Oh, I guess.
No, keep going.
Or push a function called subscribe and call publish.
I think you push a function that deletes the subscribers, for example, inside this, because this, when you get to me, when you get to the one that I've just pushed, which is a function, when you call subscribers I, and you call it on publication, you now have access to this.
You are exactly right. Unfortunately, PowerPoint compels me to force you to do these in a particular order. So please remember that. We will come back to it, okay?
Sorry, PowerPoint.
Yeah, I'm a slave to PowerPoint here. Yeah, so we're going to have to do that. So we're going to have to, but I will call on you to do that again, because you are absolutely right.
John got it.
So let's start with, how can I prevent other people from receiving messages? You almost had it earlier.
So push a function called publish. And override it?
No, it's much easier than that.
Oh.
Will this hack fail immediately on the next publish, or will it not fail until the publish after the next publish?
It should fail immediately. It will fail instantly. I'm sorry, it'll fail on the next publication.
Oh, I can just set publish. Oh, no. Can I just set publish equal to null?
Yes. Unfortunately, PowerPoint compels me to ask you to remember that one too. I tried to anticipate in what order people are going to come up with these, and
I'm sorry.
No.
We're being tasked with sabotaging, preventing all those subscribers who have previously called subscribe from getting publications when publish is called.
Right.
Okay.
Okay. So, since you're getting way ahead of me, let me show the one that we need to do first. The simplest attack to prevent people from getting publications is this one, where we simply subscribe with nothing. So that means we're going to push undefined onto the subscribers array. So when we go to do this loop, kaboom, right? And so everybody after us doesn't get any messages sent. So how would you fix that?
Solve the problem though, because people before you still get it. So
Right, but the people after don't. And
what's
so
the problem to try to prevent anyone from
we have to make sure that everybody receives every message. Now, if one person gets it, we can't say that we've succeeded. That everybody has to get it.
You can just do a type check before you tack it onto the array, correct?
We could do that. Up here, we could do type check, if type of equals function.
You should be
But-
rewrapping your call in a try catch.
Well, yeah, that's it, because if they were to pass in a function that throws, then it wouldn't do that. So,
So pubsub is something we give out to all the...
we give it to all the third parties. They all share that instance.
So really in this case, it's kind of like don't trust user input. They can send a subscriber, but they could send you a function as a subscriber, an empty string. Or
Right. Well, in this case, it could be a malicious failure, but it could also be an accidental failure. Someone might simply call it incorrectly, and we don't want the whole system to fail because of that. So this is what try catch is for, right? So we can simply catch the thing, ignore the error, and we'll keep on processing. So that's good. So we're now ready for your second observation.
Set subscribe to null.
Yeah. So we can tamper with the pubsub instance itself, and we can delete the properties, change either of them to undefined or null, or replace them with other functions that could do things more insidious, like allow only certain people to subscribe, or allow people to think they subscribed when they didn't, or to filter the messages when they publish, or to tamper with the messages when they publish. There's an infinite number of terrible variations on this theme. And so how would you fix that?
Use a setter.
I'm sorry?
So you aren't going to really expose publish so much as you're going to return a function. You're going to return a function. Returns a function. I don't know. It's something like a getter and a setter. Like you don't want to set it. They can only get it.
You could, but there's an easier thing to do than that.
Freeze the option here?
Yeah, you want to freeze it. So if we freeze the object, then all of those attacks are completely frustrated.
We can do this right now in JavaScript.
Yeah, freeze was added in ES5.
Okay.
So that's, it's in IE 9 and 10 and 11 and in all the good browsers. So we can freeze. So that completely solves this. And so that's one of the reasons why I like freeze as an object construction pattern, because there's a whole lot of stuff we'll never have to worry about if the objects are frozen. And freezing this object does not impair its ability to do what it's supposed to do. That these methods still have access to the subscribers array and still can do all of that dynamic stuff. It's just nobody can tamper with the instance. Okay, we're now ready for your next suggestion, your first one.
I forgot it. We're going to pass in, we're going to subscribe with a function that iterates through this and deletes everything.
Yeah, exactly.
Something like that.
Yeah, something like that. So that'd be something like this. So we're going to subscribe with a function which will get access to this, and then that gives us access to the subscribers array, because this is a method invocation, even though it doesn't look like a method. You know, we're calling a function that is stored in an array. We don't think of that as being a method invocation, but JavaScript does. So everything from here on will get bound to this. So in this case, we're going to set this.length to 0. That will delete all of the subscribers. But we could do much more insidious things as well. Again, there's an infinite number of bad things you can do to this object if you get access to this. And you know, so this is a big source of confusion again, right? That in JavaScript, things with brackets are method invocations, but we don't see those as method invocations. So again, this is a confusion which leads to misunderstanding of what our programs do, which make it possible for bugs and security exploits to happen.
Okay, inside this function that you've just written, this is the pubsub object, right? With its var subscribers, that's its scope, right?
Now, in this case, this is the subscribers array, because this is the method. Okay, here's your function. You pass it in to subscribe, so it gets stored in the subscribers array. And in this loop, it now gets called, but it's being called as a method. You know, there are 4 ways to call a method in this language. I think there should only be 1, but there are 4, and at least one of the forms is confusing as to which kind of invocation it is. So, how would you fix that?
Your brain says call. No?
I'm sorry?
My brain says using call.
That would be one way to do it. If we say subscribers sub I dot call and then pass in that would be one way to do it. The way I would prefer to do it, or the other thing you could do, is assign subscriber sub I to a local variable and then call that variable. Or what we could do is use for each. That I'm now distrustful of for loops in general, and I like for each much better. So I can pass to for each a function which will call each element of the function and ignore any exceptions. And I really like this. I think this is very, very nice. So so I'm not using for loops anymore. I'm doing this stuff instead. And because it's passing in each individual element, there's no confusion about how this gets called. It's never going to be a method invocation. In fact, this function doesn't even see the array. All it sees are the individual elements.
Remind us how to escape for each.
I'm sorry?
Remind us, how do you break out of a for each?
You use every instead of for each. And we would design it so that this function would always return true.
If it returns false, then it leaves.
Then, yeah, false is the exit signal.
On the previous slide, somebody wants you to clarify why does this refer to the array?
Right. So this is the function that is being executed here. Okay, and this form of function invocation is the method form. The method form will have a dot in it or a bracket in it. And so everything to the left of the last dot or last bracket gets bound to this. And that's why that happens. There's still one attack left. And this one is an out-of-order attack. That the attacker can cause a message to be delivered before another message, at least to some subscribers. And by doing so, he can create confusion in the marketplace. So how do you do that?
Meaning that the subscribers should be getting the messages in the order that they subscribed?
Each of the subscribers should get them in the order that it's subscribed, and they should also, each of them should get the messages in the order that they are sent.
Subscribe with a number.
I'm sorry?
Subscribe with a number?
No, that would cause an exception to get thrown, and we're already ignoring those.
So we're assuming at this point that we're working on the for each loop rather than the previous?
Either one, but we
Okay.
can focus on this one if you like, since we can see it. That the corrections that we have made up till this point haven't fixed this new one.
So much like we push onto the subscriber array, can't you push any of the other function operators, function methods onto that to screw with the order of it, reverse it?
No, you're talking about the first problem we did?
Yeah.
Yeah,
So-
and that one was using store because we could name where it was going to go. In this one, we haven't provided an API for doing that.
Gotcha.
And the good thing about this construction is that that's impossible because well, assuming that we fixed the thing where they can get access to the subscribers array through this, there is no way that they can add a property to subscribers except through the subscribe function.
S doesn't have access to this anymore.
That's correct.
Are we trying to get the messages out of order or the subscribers out of order?
The message is out of order.
Just set timeout. You just become asynchronous, so that would it just change where yours comes in.
Yeah, no, set timeout might be part of the solution, but it's not part of the problem.
You know, we have like wait.
We don't have wait in this language.
Yeah, and that's because that's synchronous anyways. If it was, it would
Yeah.
just cause everything to.
Exactly. And in fact, wait in a system like this is a form of denial of service attack, right? Because it stops everything.
Right.
So, yeah, so that's not part of this attack.
You know, every time somebody calls publish, a publication that's the message, right? It's going to iterate through the subscribers and call it. And then what you're saying is, I call it, and then you call it after me. You're the bad guy. You call it after me, but somehow yours jumped the line in front of mine.
Yeah. That's what we're looking for.
But you can't call it until it's finished with mine, because the process is locked. But I guess apparently I'm wrong.
Right.
Can I pass in the pubsub object to my function and then resubscribe myself in the midst of a call?
You're close. It's not quite like that, but it's that kind of thing.
Is this a vulnerability in for each?
No.
Because these are for each is synchronous.
Right.
So are we essentially creating an infinite loop based on what he said? Is that
We are not looking for an infinite loop because
Okay.
an infinite loop would be a denial of service attack. And
Okay.
someone can do an infinite loop without calling our code. They can just sit in their own code and do an infinite loop. So that's not something this code can defend against.
And inside of for each, can you change the value of S?
Yes.
So if I publish one object, and then later on I publish another object, And that second object has a function in it that sets S back to the first object. Is that a nasty thing to do?
Well, that's not likely to happen because whatever function you're going to be doing that will be created outside of the scope, and so it will not see S.
Oh yeah, duh.
Only functions in this scope can see S.
So if I pass in the pubsub object to my subscriber's function, when my function gets called, I call publish again,
Yes,
and we restart the loop from the beginning again,
exactly.
and we keep on doing that, and the end people never get it.
Right. So this is, yeah. So this is the attack he just described. So he subscribes a function which will publish. And this function gets called in the publication loop. So he can then cause his own message to get published and delivered to everybody who is after himself in the subscriber list. And in doing that, he causes things to go out of order.
Leonardo in the chat room beat us again.
Way to go, Leonardo.
Well, Vincent was the first. Yeah, Vincent beat us last time, but this time it was Leonardo.
You need to be telling us that before.
I know.
Yeah.
I didn't know exactly.
You need some glory.
Yeah.
Okay, so the reason I used the limit function that we wrote yesterday, because if I don't, then I'm just creating a denial of service attack, right? We'll keep calling it over and over again recursively, and a denial of service attack doesn't accomplish the security exploit that we're trying to do. It just impairs the system.
Oh, limit's what we wrote yesterday.
Yeah, we wrote limit yesterday, so that means when I get called, I am going to send one message, and that message will get delivered before everybody else. So, how would you fix that?
So every time somebody publishes a message, my message will go out. Oh, but it only ever happened once.
Well, but I can control it. You know, this is the simplest way to keep it from getting abusive, but obviously you could put a smarter function in there that could change its behavior every time it's called.
Right. You could type up the subscriber and make sure it's not an object, right, or a function. You type check this.